Alright, so good evening to everyone and welcome to another episode of Moyo Math. Well, of course, this Czec exam is right around the corner. It's just about a week away or 2 weeks away, and we want to ensure that we're ready for this exam. Alright, so today we'll be doing some practice questions on angles, polygons, sine, cosine, rule bearings, common questions, topics. Questions in relation to those topics you'll see in the exam. So let's make sure that we have a full grasp and understanding. So when we enter the exam, you see these questions, walk in the park. Alright, so don't forget to like, share, and subscribe to the channel. Alright, so let's go. Alright, so first question, given angles and polygons. So we have this question in the diagram below. PQ is parallel to MN, LRT is an isosceles triangle, and SLT is a straight line. So we have PQ and MN are parallel lines. So we have PQ, we have MN, we have this transversal line ST, we have this angle here which is x degrees, which we have to find. This is L, this is T, and we have this triangle here, this is R, two parallel lines, and this angle here is 28 degrees. And of course that triangle LRT is an isosceles triangle, so it means that if this is the apex of the triangle and the side opposite is the base, and these two sides are equal, we know that for an isosceles triangle. And for an isosceles triangle, we know that the two base angles are also equal. So to get those two base angles, what we'll do, we'll simply subtract 28 from 180, then we divide by 2. So 180 subtract 28 equals 152 divided by 2 over 76. So this angle here, it is 76 degrees, 76 degrees. But they wanted to find x. And remember from your knowledge of angles, this is your z shape. When two lines are parallel and you have that z shape, which is called alternate angles, then we know that this angle, if it's 28, you see the z shape here, look at the z shape. So if this angle is 28, this angle here is also 28 degrees. So we can find x. X will be equal to, easy, 76 plus 28. And 76 plus 28 will give us, that'll give us 104 degrees. And x will be 104 because when two lines cross, at a common point, then two opposite angles are said to be equal. So this will be vertically opposite. Right? So vertically opposite angles. So this is 104, then angle x will also be 104 for vertically opposite angles. Alright? So that's angle x. Let's look at another. So we have this question here. So we have this diagram. So that diagram drawn, it says in the diagram below, not drawn the scale, shows two straight lines. You have two straight lines, JK, so you see JK and LJ, JL, intersecting a pair of parallel lines, EF and GH. Determine, given reason for each of the answers, the value of x. We have to find y, and we also have to find z. Right? So let's look at that question and see how to deal with such. Alright? So we have here 1, let's find x. So to find x, what I'll do, let me draw the diagram. We have these two parallel lines, alright? This is y degrees, that is 100 degrees. This is x degrees, this is 120 degrees. And we want to find x, y, and w. So x will be straightforward. So x will be equal to, this is a straight line, hence have a straight angle. So if you have straight angles, it's equal to 180 degrees. So all you have to do is to subtract 120 from 180, yeah? And 180 subtract 120 will give us 52 degrees. So the angle at x will be 52. So you see this angle x here, that's 52 degrees. And to find y, what we can do is to use co-interior angles. You see I have that box shape. So for the box shape here, these two interior angles, A and B, when you add them, you must get 180. Or if you know one angle, you can easily find the other by subtracting from 180, right? This is known as co-interior angles. So what you'll have here is, look at the box shape. Two parallel lines, and you have the box shape here. So therefore, if this is 52, we can subtract 52 from 180. So y will be 180 subtract 52, and 180 subtract 52 will give us 128. We can even use corresponding angles too. So you have the F shape here. This angle is equal to that angle. This is corresponding angles. So for corresponding angles, which will be your F shape, if this is 128, this is also 120, because you know, for corresponding two parallel lines, then these two angles are equal. If this is 128, that's 120. So you can use either co-interior or corresponding, but I'll use co-interior. Because remember the arcs given reason, right? And this will be for straight angles. Alright? So let's look at now. So this is 128. So let's look at now finding W. So they want us to find W. So we're going to find W. Easy, if you look W fall within a triangle. And what we can do is to find, using straight angles, we can find this angle, we can find that angle, and of course the sum of three angles of a triangle add to give 180, so we add the 2 and subtract it from 180 to find W, straightforward. So let's get this angle here. You know this is because of the F shape, so you have the two parallel lines, you have the stem of the F. If this is 52, this is 52, or you can say 128 from 180 will be 52. If this is 100, again, straight line, straight angles, 100 from 180 will give us 80. So we can say that W, so W part 3 is equal to, we're going to say 180 subtract 52 plus 80 degrees. 180 subtract 52 plus 180 will give us 52 plus 80, sorry. Will give us 132. And 132 from 180 will give us 48 degrees. And the reason will be the sum of three angles of a triangle. So if a triangle, you know all three interior angles must add to give 180. So the sum of three interior angles of a triangle is 180 degrees. Alright? So you know that angle W is 48, straightforward. Alright? So let's look at next. So let's look at this question here. Right, so don't forget people to like, share and subscribe to the channel. Very good questions, work that we're doing here to help benefit students to improve their knowledge and understanding of the mathematics. Alright, so that's all we want to do. We want to make sure that everyone can improve in their mathematics. So let's look at this question here. The diagram below not drawn on the scale shows two straight lines. You have two straight lines. TU, VW. Well, two straight lines as well. You have, well, these two lines, TU and VW, are parallel lines, but then you have two straight lines, PQ and RS, intersecting a pair of parallel lines, TU and VW. Good? Determine the reason for your answer as the value of x. So let's find x. So we have this diagram here, so let's quickly draw the diagram. So you have these two lines, and you have these two parallel lines here. Right? So this is T, that's U, two parallel lines. This is V, that's W. This is 54 degrees. This is Y degrees. This is 115 degrees. And this is X degrees. So we find an X. X straightforward, real straightforward. So 1X. And using the Z shape again. Z shape. Two parallel lines. This angle is equal to that angle. The Z shape will be alternate angles. Just remember that. Alternate angles. So when two lines are parallel, just note, once you have that Z shape, alternate angles will come into play. That angle is equal to that angle. So if this angle is 54, look at the Z here. Wap, wap, wap. You see that Z shape there? So this is 54, and X will also be 54 degrees. And it states given reason, right? So you have to give a reason, which will be for alternate angles. And now let's find y. So this is y here. So to find y again, we have two parallel lines. And what I'm seeing there is a box shape. I am seeing this box shape here. If that's A, that's B, then when you add A and B, it must give 180. If you know one, you can find the other, and this is known as pointing angles. So, look at the box shape here, look at co-interior. Wap, wap, wap. See the box shape here? So therefore, 2 angle y degrees will simply be, because of the box shape co-interior, is going to be 180, subtract 115, and 115 from 180 give us 65 degrees. And the reason, co-interior angles. It's always important to know the reason, right? Because most times in these questions with angles, we'll always ask you to give a reason. So we should know the different types of angles when lines are parallel and know all the angles in fact. Alright, so let's move on to the right, so looking at here, this is a polygon. A polygon is a figure with many sides, starting from a triangle which has 3 sides, a quadrilateral 4, a pentagon 5, hexagon 6 sides, and so on, right? So looking at this question here, you have this regular polygon, or in this case a regular hexagon. Is a hexagon where all 6 sides are the same length, right? So that's what I call a regular. So all the sides will be of the same length, and all interior angles all will be of the same size. All will be x. If you want to name the angles x, right? So all 6 sides will be of the same length, and all interior angles are the same size. So I wanted to show that the angle PQL. So where is PQL? It's 120. This is PQL here. PQL. Look at the letter in the middle. This angle here we're looking at. That's PQL. Good? So for us to find that angle, easy to prove and show. We want us to show We know that because it's a hexagon, that hexagon has a regular hexagon regular. You know the number of sides will be 6 for hexagon, 6-sided figure, polygon. And you know that the sum of interior angles, you should know this formula when it comes to polygons. The sum of interior angles is n minus 2 in brackets times 180 degrees. Or sometimes you can use 2n minus 4 in brackets times 90 degrees. Any one of the two will be correct. And if I go with n minus 2 times 180, the sum of interior angles, which means all these interior angles when they add up will give us what? So I know the number of sides, it's what? 6. So that's 6 minus 2 times 180. That's 4 times 180. And 4 times 180 will give us what? That's 720. So the sum of all those interior angles inside a hexagon, that regular hexagon is 720 degrees. But they want us to show that this angle here is 120, and that's straightforward. Because one angle PQL, because the sum of all interior angles will be 120, and all angles are the same size, and you have 6 angles. To find the size of each one of them, which includes angle PQL, will be to divide 720 by 6, which is 120 degrees. And put hence show. Because I asked you to show, right? Show that. So when you ask you to show in math, of course, it will show by working, and it will state hence shown at the end. Alright? So let's get another. Right, so this part of the question, calculate angle LWX. So what is a find angle LWX? And that'll be straightforward. So LWX will be what? So first you have to identify where is angle LWX. So remember the letter in the middle is where the angle is always located, right? Between the two lines LW and XW. So we have LWX, looking at this angle here. See the angle you want to find. That's the angle you want to find, right? So I'm going to pull out my hexagon here. Alright? I have 2 parallel lines here. Right? And I want to find, this is LM X N Y O P Z Q. Good? And they want me to find angle LWX. That angle is where? Here. This is W, right? LWX. So this is the angle I'm looking at here. I want to find this angle. So I'm going to find an angle. We just work out all the interior angles of this polygon, you know. We got this angle here to be 120 degrees. That's all. This angle here is 120 degrees. And look at it, you have the box shape. Look at the box shape here, because remember, these lines are parallel, right? So when they are parallel, just remember, alternate corresponding cointerior will come into play. The box shape is cointerior. Look at the box shape here. 2 angles, when you add them, you get to 180 degrees. So if you know one angle, you can find the other. So therefore, this angle, LWX will be 180 minus 120, which will give you what? 60 degrees. Yeah? So that angle there will be 60 degrees. That's the angle LWX, 60 degrees. Straightforward. So let's look at another question here. So don't forget, tell your friends, tell everybody to like, share, and subscribe to Moyo. Right? So let's look at, in the diagram below, now draw the scale. Of course, we have this pentagon. A pentagon is a figure with 5 sides. Good? And it says here that angle BAE is 108 degrees, angle ABC is 90 degrees, angle AED is 80 degrees, angle ADC is 57 degrees, and they told us here AE is parallel to C, which is C by the 2 arrows there, right? The parallel. So they want us to calculate the size of angle, the angle mark X. So we're going to find this angle here, X. So to find X, you could do, well, I'm saying here 1 to find angle X. I could see with these Z shape. Once two lines are parallel, just keep in mind those triangles will come into play, alternate corresponding co-interior. So I'm seeing where I have my Z shape here. So this is 57. This angle here is also what? 57 degrees for alternate angles, yeah? And what I can do, I can add these two angles and subtract it from 180 for sum of 3 interior angles of a triangle, right? So this will be 180 degrees subtract 80 plus 57. 180 subtract 80 plus 57. That's 137. And 137 from 180 will help us to find X. That's 43 degrees. Angle X, 43 degrees. Alright? And I'll give a reason, even though they didn't ask for a reason, but I'll still write it. Sum of 3 interior angles of a triangle is 180 degrees. Good? And I'll also include and alternate angles, right? So you use those two to help us to find X. So let's find Y. 2. So you want to find Y now. This is Y here, right? So X is 43. So it means that this entire angle here, that's 43 plus 57. That's 100 degrees, right? This is 100. Now, that's a polygon, and you want to find Y. So the sum of all interior angles of a polygon, right? We have to know. And once we find the sum of interior angles of this polygon, which is a pentagon, a 5-sided figure, then I can find Y, right? Because all these angles must add to give me that sum of interior angles. So let's find the sum of interior angles of a pentagon first. So sum of interior angles of a pentagon. Of course, using our formula, I'll use n minus 2 times 180. So the number of sides in a pentagon will be 1, 2, 3, 4, 5 sides. So that's 5 minus 2 times 180. 3 times 180. Which will give us 540, right? So if we know the sum of interior angles of that pentagon is 540, then let's add up all the interior angles we have in that pentagon right now, put it equal to 540 and find Y. So that's what? 80. Therefore, 80 degrees plus 108 degrees plus 90 degrees plus Y degrees plus this entire angle here is 100 degrees, right? So those are 5 angles, 5 interior angles, that is equal to 540. So that will be equal to 540. So let's add. So that's 80 plus 108 plus 90 plus 100 will give us 378. So 378 degrees plus Y degrees is equal to 540. And then to find y, let's simply subtract what? 378 from both sides, right? So y is what? 540 minus 378. What's 540 minus 378? 162. So angle y, 162 degrees. Right? So we can show you when it comes to a polygon. We should know this very important formula here. See this formula here? N minus 2 times 180, or 2n minus 4 in brackets times 90. Anyone is give the same answer. Right? Both are the same thing. Alright, let's look at. Right, so moving on to sine rule and cosine rule. So sine rule and cosine rule. So we have here, so we have this question. On the diagram below, not drawn the scale. TU is 8 meters, TW 10 meters, VW 11 meters, angle UTW 60 degrees, angle WUV 40 degrees. They want us to calculate the length of UW. Where UW? This is UW here. So they want us to find the length of UW. So what are we going to do? So this is where you have your cosine or your sine rule will come into play, because this triangle UTW is not a right angle triangle, and that's not a right angle triangle. So what you have is this. So this is so I'm going to pull that triangle from out of the diagram we have here. So this is T U W 60 degrees. This is 10 meters, 8 meters. Now to find TU, or sorry, to find UW, what we're going to do is to use the cosine rule here. You know why? Because with the cosine rule, the side you have to find when you look opposite to that side, that unknown side. Once you have two known sides, and what you call an included angle, those two known sides meet to form that angle, which is called an included angle. You know, one time you're using the cosine rule. So look at the side you have to find, and when you look opposite to that side, you see two known sides and an included angle. Two sides meet to form that angle, you're using the cosine rule. So one, using the cosine rule. And this will normally you see in the formula sheet too, right? So what you do, you start by labeling. The side opposite capital T, that's common T, always label using common letters, not sine, cos, tan, no, common letters. So look at the vertex T, the side opposite common T. Vertex U, side opposite common U. Vertex W, the side opposite common W. And then what you can do is to use your cosine rule. The cosine rule is this. The unknown side squared is equal to W squared plus U squared, or U squared plus W squared, doesn't matter the order, minus 2W cos the angle at T, which is the included angle. This is the cosine rule, very important rule to know. So this will be common T squared is equal to W squared, 8 in bracket squared, plus U squared, 10 in bracket squared, minus 2 times 8 times 10, all in brackets, cos 60 degrees, which is the angle at T. This will be T squared is equal to 64, that's 8 squared, 8 by 8, 64. 10 squared is 100. This is negative 2 by 8 by 10, and one time cos multiplied by cos 60, right, so we're supposed to get negative 80. Yeah? So you can put it in the calculator, negative 2 by 8 by 10 multiplied by cos 60. Put that entire thing into the calculator. And what you're going to get is negative 80. So you should put in negative 80. Alright, so this will be T squared is equal to 64 plus 100. That's 164 minus 80. So 164 minus 80 will give us 84, and therefore T is the square root of 84. And what's the square root of 84? So this is UV, right? Or UW, sorry. UW is also common T, and that is the square root of 84. Did it specify any number of decimal? No. So what we'll do, we will approximate it to the corrected three significant figures. So this is 9.165, and corrected three significant figures. This is 9.17 meters, corrected three significant figures. So remember, for significant figures, we count from the first non-zero digit from the left, 1, 2, 3. Look at the number after, which is 5. Once it's 5 or more, we add 1 to that 6 to become 7. Alright? So that's the length of UW. Okay? Now, let us find the size of angle UVW. Now, where is that angle located? So UVW, look at the letter, and the middle is where the angle is located. So the angle is here. So you want to find that angle. So we're going to find that angle. Yeah? Of course, this length, or we could see that all the numbers are correct. Approximately correct to the nearest whole number. We didn't specify, so let's put it correct to the nearest whole number. So to the nearest whole number, I'll put 9 meters. To the nearest whole, right? So approximately to the nearest whole, 9 meters. This is 9 meters here. Alright? So UW, 9 meters to the nearest whole number. So let's find the size of that angle. UVW, how are you going to find that angle? This is where you're going to use your cosine, your sine rule. So the sine rule is used to find the length of a side or the size of an unknown angle. And the sine rule is used to find an angle when you have two sides and one angle. Not an included angle. The included angle is only for the cosine rule. So once you have two known sides and an angle, then we can use the sine rule to help us to find an unknown angle. Alright? So let's look at part 2. So part 2, what I got, pull out a triangle. This is the triangle here. So it's U, W, V. So you want to find this angle here, right? And this is 9 meters. This is 40 degrees. This is 11 meters. So what we look to find this angle here, we're going to use the sine rule. Once you have two sides and one angle, keeping in mind the angle must not be included, eh? Alright, included is where two known sides meet to form an angle. That's an included angle. In this case, that is not occurring, but you have two sides and an angle. So you're using the sine rule to find the unknown angle. So how are we using the sine rule with the label? The side opposite capital U is what? Common U. The side opposite capital W, common W. The side opposite capital V, common V. The sine rule is about ratios. You see that in the formula sheet too. It's about fractions or ratios. So the first ratio of fraction will always, I always advise students that the first ratio of fraction have the unknown quantity. The unknown quantity is the angle they want to find at V. So let the first ratio involve everything with V, which will be common V over sine the angle at V. That's the first ratio. And you allow the other ratio to be one where you have information for both side and corresponding angle. This is the side 11 meters, and the side angle opposite it, which is known as the corresponding angle. You also have information for that. So the other ratio in this case will be common U over sine the angle at U. Yeah? So once you create the equation for the sine rule, let's just simply substitute and look at what we have to find. So this is common V, which is 9 meters, over sine the angle at V, that's the angle you want to find. This angle here is equal to common U, which is 11 meters, over sine the angle at U, which is 40 degrees. Once you have two single fractions on either side of the equal sign, what you do, you cross multiply to remove it from the fraction form. So this will be 11 multiplied by sine the angle at V is equal to 9 multiplied by sine 40. To get sine the angle at V by itself, you have to remove the 11. So we will divide 11 on both sides. So when two 11s divide each other, you're going to be left with sine the angle V is equal to 9 multiplied, let's look what we have on the left. So in brackets, 9 multiplied by sine 40 divided by 11. That'll give you 0.5259. And normally advise students take about 4 places or 4 to 5 places, because it will help you get a better approximation to your answer, right? 4 to 5 places after the point. Alright, you're not approximating, just take about 4 to 5 places after the point. And therefore to get V by itself now, I need to remove sine, which will come across as sine inverse of 0.5259. Let's find sine inverse of that. So angle V will be sine inverse shift sine of bracket 0.5259 close brackets. Right, so we're going to get 31.7 degrees. I'll approximate it to the nearest whole. Right, so here angle V 32 degrees to the nearest whole number. Right? So 32 degrees at angle at V will be equal to that to the nearest whole. Now let's look at part 3 again using the sine rule. Part 3. We want to find the angle, the area of the triangle TUW. So we want us to find the area of that triangle TUW. So we erase. So what is to find the area of triangle part 3? Area of triangle TUW. So this is triangle TUW here. This is 60 degrees. This is 8 meters, 10 meters. So to find the area of that triangle, now we are accustomed when it comes to the area of a triangle, we are accustomed using base by height all over 2. Right? We are accustomed using that. But we're not going to use that here. Alright? Because this has no perpendicular height. You're not seeing any line, perpendicular line drawn to make the base at right angle. So we can't say perpendicular, use that formula base by perpendicular height over 2. But we're going to use this formula. When you have two known sides, two sides that are known to you, you have the lengths of those two sides and they meet to form an angle which you call the included angle. Just remember that as included angle. The area of this triangle is this formula. A half times A times B by sine the angle theta. Get familiar with this very important formula for the area of a triangle, which you see in the formula sheet also, right? You also see that in the formula sheet. So the area of this triangle here, if you look, you have two known sides, you have the included angle, so the area is a half times, and let me label common U, common W, common T. My two known sides is a half times common U times common W by sine the angle at T. So that's my formula I'm going to use to find the area of that triangle TUW. So A will be a half times common U, which is 10, common B, which is 8, by sine the angle at t 60 degrees. So this will give us A is equal to 10 by 8 is 80, 80 divided by 2 is 40, 40 sine 60 degrees. So this is A, which is 40 multiplied by sine 60, and make sure the calculator is in degrees when you're finding the area and you're finding the sine of an angle, right? Make sure the angle, the calculator is in degrees, okay? Because the angle is in degrees, right? Not radians. So this will be 34.64 meters squared, and approximate to the nearest pole. So to the nearest pole area, 35 meters squared to the nearest pole number. Alright? So making sure that we're clear on how to treat with sine, cosine rule. Alright, let's look at another. Alright, so let's look at this question here. So, don't forget to like, share, and subscribe. Tell all your friends, tell them to look at the videos normally prepared by Moyo, Mr. Moyo, and let them like, share, and subscribe to the channel, right? So, let's look at this question here. So this question, we want us to find the length of QS. So again, this is very similar to the question we just did. So to find the length of QS, what we're going to do? We see here, I'll pull out this triangle. This is 9 meters, 12 meters, 60 degrees. So to find the length of QS, we're going to use the cosine rule because you have two known sides and they need to form this angle called the included angle. So our label, common R, common Q, common S. So using the cosine rule. Alright, this is a non-right angle triangle, so we use the sine or the cosine rule, but we're using the cosine rule because we have two known sides that meet to form an angle called included angle. So this will be what? R squared on known side squared is equal to S squared plus Q squared, or Q squared plus S squared, it doesn't matter the order, minus 2SQ cos the angle at R. This will be R squared is equal to S, which is 9 squared Q 12 squared minus 2 by 9 by 12 cos 60. This will be R squared is equal to 81 plus 144. This is, let's work out, we put everything into the calculator, negative 2 by 9 by 12 multiplied by cos 60. This is negative 108. And this will be R squared is equal to 81 plus 144, which is 225 minus 108. So 225 minus 108, 117, and therefore R is the square root of 117, and the square root of 117, that will give us, right, that will give us 10.81. But I want it correct or what? One decimal place. So you know that the length of QS is 10.8 meters to one decimal place. Good? So that's part one. The length of QS using the cosine rule. Now, part two. Find the measured angle QTS. So angle QTS so part two, so angle QTS, where is angle QTS located? Angle QTS, you know, to find an angle, that symbol means angle. So this will be located at the letter in the middle, which is at T here. So I want us to find that angle. This length, previously, we got that to be 10.8 meters. Done? So, let me pull out the triangle. This is Q, T, S. This is 10.8 meters. This is 40 degrees. This is 13 meters. You want to find this angle. So, one-time triangle is not a right angle triangle. So, clearly it's a sine or cosine rule. And we know we're using the sine rule here because you have to find an angle and you have information for two sides and one angle. The angle is not included, right? So once it's not included, then you know you're using a sine rule. You have two sides and an angle, so you know you're using a sine rule to find the unknown angle. So using the sine rule, so because I want to find this angle at T, then my first ratio will have everything with T. So it's going to be common T over sine the angle at T. And the other ratio is one where there's information for both side and angle. This will be common Q, and don't forget to label the sides. So this will be common Q over sine the corresponding angle at Q, because you have information for both side and corresponding angles. So it's common Q over sine the angle at Q. Good? So this will be what? 10.8 over sine the angle at T is equal to Q, which is what? 13 over sine the angle at Q, 40 degrees. And what we'll do here, let's simply what? Cross multiply to remove it from the fraction. 13 sine the angle at T is equal to 10.8 by sine 40. And what we'll do, we have to get sine T by itself, so let's remove the 13. Let's divide both sides by 13. So that's 13 sine the angle at T divided by 13, 10.8 multiplied by sine 40 over 13, divided both sides by 13. So you 2, 13 will cancel out, you end up with sine T. And that will be what? 10.8. That in brackets, 10.8 multiplied by sine 40 divided by 13, right? That gives us 0.5340. Take about 4 places after the point. And therefore to get T by itself, you have to remove sine, right? So now remove that sine, to come across as what? Sine inverse. 0.5340. Let's find sine inverse of that. Let's see what we're going to get. That gives us 32.2 degrees. 0.323 degrees to 1 decimal place. But I want us to put it to 1 decimal place, right? 1 dp. Yeah? And let's look at part 3 now. We want us to find the area of the triangle QRS. So what we'll do, so we get here the triangle, straightforward. So remember, whenever triangle, it's not right angle, this is QRS here. You want to find the area of the triangle, part 3. This is QRS. This is 60 degrees. This is 9 meters, 12 meters. You have a triangle where you have 2 known sides and an included angle. So to find the area one time, what are you going to use? This is what? Common Q, common S, common R. So the formula is a half times common Q by common S by sine the angle at R. Just remember this very important formula for the area of a triangle, which is a half times 12 by 9 by sine 60. So that's what? 2 to the 2, 1, 2 to the 12, 6. That's 6 by 9 by sine 60. Right, 46.7, well, to one decimal place, 46.8 meters squared is the area of that triangle QRS. And then they want the perpendicular distance from Q to RS. That perpendicular distance. Perpendicular means when one line meets another at right angles. So let me draw a perpendicular line from Q to RS. This is it here. Meeting at right angles. Good? So meeting at right angles. Wow. So to find the perpendicular distance from Q to RS, which is this distance here, what I can do part 4, can you see a right angle triangle? This is 60. This is 9 meters. Alright? And what we can do is to use shrinks. This is Q, this is R, Q. And let me call this T. So pulling out that triangle, it will help me to find this perpendicular distance from Q to RS, which I call QT. So this will be what? Using, because it's a right angle triangle, I can use trigonometry, sine, cos, tan. This will be opposite, the side opposite 60. This is hypotenuse, the side opposite the right angle. And this is the adjacent side, the remaining side. And because I want to find opposite, given hypotenuse, I know the trigger function I'm going to use will be sine theta. So it's going to be sine theta is equal to sine opposite all over hypotenuse. Sine 60 degrees is equal to a side opposite, which is QT, over the hypotenuse, which is 9. I'll put sine 60 over 1, and I'll cross multiply so I can get QT by itself. So this is QT is equal to 90 by sine 60. So 9, by sine 60. So that's 9 multiplied by sine 60, which will give us 7.8 meters, will be QT. Yeah, that's the distance from Q, perpendicular distance from Q to RS. Alright? So let's move on next to bearings. Right, so we can have bearings. Now remember, what's a bearing? A bearing is an angle, and what it does, it shows the position of one object relative to another object, right? So that's simply a bearing. It's an angle, right? And with this question here, two ports EG are on level ground. Level ground is the ground you're all standing on. So you have these two ports EG. This is your north. This is F. And this is eta. This is 52 degrees. This is 245 kilometers. Good? So it says here two ports E and G on level ground. 245 kilometers apart. So E and G are level ground, 245 meters apart. The bearing of E from G is 302 degrees. The bearing of E from G is 302. So let's put that bearing on the diagram one time. So a bearing is an angle where you start from the north line, because it said E from G. So from G, you make sure that north line is there, which is already given. And you move always in a clockwise direction to the line connecting E and G. So this entire angle here is your bearing of 302 degrees. Then, a ship is anchored at F, some distance away from G, on a bearing of 220 degrees. Angle EFG is 52 degrees, you can see. This information is shown on the diagram below. So they want on the diagram to insert the angle or the bearing of 220 degrees of F from G. So where's that angle? F from G, I set up my note, which is already there. And my bearing, I always move in a clockwise direction to the line connected, in this case, F and G. So this is 228 degrees. And now they want us to determine, so this is part A, we've shown part A here. Part B, determine the value of angle FEG. So FEG. FEG, this is the angle we want us to find here. So angle FEG. So this angle is easy to find, because if this entire angle here or bearing is 302 and this bearing here is 228, we need to find this remaining piece. All I have to do is to subtract 228 from 302, which will give me 74 degrees. So this is the piece here, from here to here, that is 74 degrees. Okay? And if that's 74, then to find this angle, FEG is going to be 180, subtract 52 plus 74. 180 subtract 52 plus 74. 126. So 126 degrees from 180, that's 54 degrees. So this angle here is 54 degrees. Alright, let's look at the next part of this question. So they want us to now calculate the distance GF, which is the distance the ship is from port G. So GF, we want this distance GF. So to get this distance GF, let's see. Right. So to get this distance GF, what are we going to use to find GF? Now, to get GF lies within this non-right angle triangle. What I'll do, I'll pull out the non-right angle triangle separately. So let's pull out the non-right angle triangle separately. This is it here. This is E, G, F. This is 54 degrees. This is 52 degrees. This is 245 kilometers. So in a non-right angle triangle, when you have to determine the length of an unknown side, then what you will do, once you have information for two angles on one side in that triangle, then what you will do is use the sine rule to help you to find the length of GF. So using the sine rule here to find the length of GF. So using the sine rule, so we're going to part 2. Using the sine rule, of course we label this is what? Common E, common F, common G. And because we want to find this side of common E, let always the sine rule, allow the first ratio to have the unknown. So because you want to find the side GF, which is also common E, my first ratio will be common E over sine the angle E is equal to my other ratio will be one where there is information for side and corresponding angle. So that will be what? Common F over sine the angle at F. So it's going to be common F over sine the angle at F. So common E over sine the angle at E, which is 54 degrees, is equal to common F, which is 245, over sine the angle at F, which is 52. And what do? We cross multiply. This will be E multiplied by sine 52 is equal to sine 54, 245 multiplied by sine 54 degrees. This will be E multiplied by sine 52. I'm going to divide both sides by sine 52. So I can get sine E by itself, and that will be 245 multiplied by sine 54 over sine 52. My two sine 52s will cancel. I'm going to get E by itself. Let me work out what that is equal to. In brackets, 245 multiplied by sine 54, close brackets, divided by sine 52. Right, so I'm going to get 251, and then they ask approximate to any, let's see if they ask approximate, they didn't specify. So what I will do is approximate correct to three significant figures. So this is kilometers. So it means that GF, which is also common E, will be equal to three significant figures, 252 kilometers to three significant figures. So we come from the first non-zero digit from the left, 1, 2, 3. I look at the number after, which is 5. Once it's 5 or more, I add 1 to my 1 to become 2. Alright? Now let's look at the last part of this question. Indicate the point H on the line EF, so this is EF, so what is to indicate the point H on the line EF, such that GH is the shortest distance from G to EF. So GH is the shortest distance. So I'll put H because what I want us to do is to find GH after. And if I place H here, then look at what's going to happen. If I draw a line from G to H, then what I'll have here is a right angle triangle, and that will help me to find the length of GH, distance GH. So that will be the shortest distance from G to EF. Alright? Creating this right angle triangle, which in turn will help me to find GH. When you find GH, so therefore, GH, so part B, GH, I'm going to pull out this triangle. So this is F, this is H, that is G, this is my right angle, this is 52 degrees. And previously, we would have worked out GF. Previously, we got GF to be, let's try to remember what we got GF to be. Right? And sure, we'll put it on the diagram. GF previously, I think it was think it was 282 kilometers. Let me just quickly double check it. This will be E all over sine 54, and this will be 245 all over sine 52. Right, so let me just double check here. I forgot what E, what G, I forgot to write it on the diagram. But let me work it out quickly. 245 multiplied by sine 54 divided by sine 52. Right, so 250, I think it was 252, right? To be nearer to three significant figures, 252 kilometers. So take another right angle triangle, the hypotenuse is 252 kilometers. So let's find GH. So again, using trigs, this is opposite. Hypotenuse, adjacent, I want to find opposite given hypotenuse, and now I'm using sine theta is equal to sine opposite all over hypotenuse. Sine 52 degrees is the side opposite, which is GH, over the hypotenuse 252. And then what do? We cross multiply. GH is equal to 252 multiplied by sine 52. And therefore GH is equal to 252 multiplied by sine 52 will give us 198.5 kilometers, and to the nearest correct to three significant figures, that's 199 kilometers. The three significant figures. That's the distance GH. Alright? So let's look at one more question on bearings. So one more question on bearings. Right. The diagram below, not on the scale, shows the route of a ship cruising from Palm City P to Quayton Q and then to Riverton R. The bearing of Q from P is 133 degrees and the angle PQR is 56 degrees. So we have this diagram here. Let's put up the diagram. So we have this diagram. I have my north line. This is Q. This is 56 degrees. This is W. This angle is unknown. This is my north line. This angle here, it is 133 degrees. This is 290 kilometers, this is R, and this is P. So they want us to calculate what W is equal to. So W will be straightforward now. Of course, this is a straight line, a north line, north south, that's a straight line, hence this is 180 degrees. But I need to get this angle here first. And to get this angle here, again, I have two parallel lines, which are my two north lines. And remember, alternate corresponding point here will come into play here, right? So to get this angle, let me call this angle NQP or PQN, any of the two. Angle NQP is equal to 180 for co-interior angles, right? Minus 133. 180 minus 133 will give us 47 degrees. So this angle here is 47 degrees. Alright, I'll use co-interior angles. So that comes into play with bearings also. And therefore, W will be 180 subtract 56 plus 47 degrees. 180 subtract 56 plus 47, 103. So 180 minus 103, 77 degrees. So W is equal to 77 degrees. Yeah, so this angle here is 77 degrees. And then they ask us, determine the bearing of P from Q. So remember what's a bearing? So this is part 1 here, right? Part 2, determine the bearing of P from Q. P from Q. So from Q, I set up my node, which I already have. And remember P from Q. So you're setting up your node at Q. And you move in a clockwise direction all the way around to the line connecting P and Q. So this entire angle is your bearing of P from Q. And how are you going to find that angle? Very straightforward. This here is a straight line and straight angle. So I know from here to here, it's 180 degrees. And I will add 77 and 56 to help me to determine what's the bearing of P from Q. So the bearing of P from Q, it is equal to 180 plus 56 plus 77, which will give us 180 plus 56, 313 degrees. That's the bearing of P from Q. Yeah? And let's look at now, calculate the distance. So this entire bearing here is 313 all the way around, right? So that's the entire bearing, 313 degrees. So now they want us to find the distance RP. So this is the distance RP here. They want us to find that distance. Okay? So how are we going to find that distance? So, right, so this is 210, right? So this is 210 kilometers. So to get that distance RP, what we're going to do is we're looking at this non-right angle triangle which I'll pull out. So let me pull out the triangle. PQR. This is P, Q, and R. That non-right angle triangle. This angle here is 56 degrees. This is 210 kilometers. This is 290 kilometers. What do we observe? We have information for two sides and the included angle. So one time we're using the cosine rule to help us to find this distance RP. So I'm going to label common Q, common P, common R. So using the cosine rule, because we have two known sides and the included angle, to find the unknown side, always the opposite. I want to see if that occurring, two known sides and an included angle, one time is the cosine. So it's going to be common Q squared is equal to common P squared plus common R squared minus 2PR cos the angle at Q. So this will be what? Q squared is equal to P 290 squared R 210 squared minus 2 by 290 by 210 cos the angle at Q, which is 56 degrees. So 290 all squared will give us common Q squared. 290 by 290 is 84100. 210 by 210, 44100. And let's work it out. Negative 2 by 290 by 210 multiplied by cos 56 degrees will give us negative 68109.69564. And let's work it out. This will be Q squared will be equal to 84100 plus 44100 will give us 128,200. And we'll subtract from that 68,109.69564. So Q squared is equal to, let me subtract those two, let's see what we're going to get. So this is 128,200, subtract 68,109.69564. Right, we're going to get 60090.30436. And to get Q by itself, I have to now find the square root of 60090.30436. And let's work out what that is. So the square root of 60090.30436 will give us 245.13. And did they specify? Let me see if they specify. I didn't specify, but I will approximate my answer correct to 3 significant figures. So it means that the length PR or RP is equal to 245 kilometers correct to 3 significant figures using the cosine rule. Alright, so that will bring us to the end of today's session. So I hope we understood all that was taught. Please look at the videos, make sure that you like, share, and subscribe. Make sure you look at the videos thoroughly to understand all that is being taught. Right? The aim is to ensure that students can become better and stronger mathematicians. This is what Moyo Math is all about, to ensure that we can strengthen our knowledge and our understanding and grow to love mathematics. Alright? And of course, enter our exams and do excellent papers and achieve excellent results. So that's it. Have a great evening, and I'll see you all in the next episode. Take care, everyone.